Hello, checking 1 2, checking 1 2. Hello. Cool, that appears to be working. So, just present this to the screen. Check the volume levels. Lighting seems okay. You can see me. That's good. Excellent. We're in business. Okay guys, thank you all so much for coming. We will begin in just about 90 seconds time. I did have to change the link just an hour ago after I did the sound check, so maybe people will come along in a little while as we are talking. So thanks very much for your patience. We'll start as soon as the clock strikes 6. Thank you. Okay, hello, good evening, good morning, good afternoon, wherever you are in the world. Thanks very much for coming along to my second ever live stream. I think that the message will get out shortly, but hope you're all well, in good spirits, and maybe the people that are here have had a chance to have a look at the IA shared into the Chemistry Teachers Facebook group, and we'll go through that first of all. So let's kick off. So the first IA which I shared for marking was the effect of temperature on the rate of reaction of crystal violet. First thing I noticed, this is a very focused research question. This was a real candidate from last year, and I did ask her permission to use this today, and she was quite happy for us to use it as part of this training. Okay, I'm not going to read the IA verbatim as we go through it. I am going to, though, however, highlight the comments that I would make if I were to be moderating this IA. Okay, so she starts off, what's the effect of temperature? That's good. On the rate of reaction, kind of standard. And we can insert any number of chemicals here on the right hand side and make an internal assessment out of that. She says that she enjoyed kinetics. Then she starts to make some mistakes pretty quickly. We learnt about the Rates law and activation energy of inorganic compounds in class, and we're introduced to an inorganic compound, crystal violet. Clearly, crystal violet is an organic compound. It doesn't immediately want me to mark it down, but it does raise a question mark in my head about how much, any further errors, how much personal engagement this student has got. In the investigation, she found the initial rate by first finding the rate equation, and I'm scratching my head thinking, surely you find the rate first and then you find the rate equation. So it seems to be back to front, so I put it down here the wrong way around. It should be the initial rate, then the rate law. She then redeems herself quite well. There's pretty good research in the personal engagement part. She's got things about resonance of nitrogen atoms. She's got things about conjugation, single and double bonds, which is not on the IB syllabus, so that shows some personal engagement and exploration. It's a highly conjugated system with a low energy difference. That's great. Again, this is beyond the IB syllabus. That shows some exploration. You don't have to do that, but it really does help. Here's a nice structure of crystal violet, the protonated amine at the top. We then got a bit of basic background as we go through the IA. And she's got the equation for the reaction of crystal violet with hydroxide ions forming CvOH. Now the paper that she references is quite a well-known paper. I've seen it used a couple of times. There's no problem with that. She's made it her own, but I am aware that it's not an entirely original method which the student is using. We've got the second rate equation where K1, so now this is new, this is a pseudo rate constant. So this incorporates the true rate constant K that we're familiar with and the concentration of hydroxide ions. It does show exploration beyond the syllabus. When you look at the research paper here, you find it is actually lifted from that paper. Not a big problem. She's read around the subject. She's done a bit. That's good. Okay. It did take a little bit of digging to find out where this was. It wasn't an actual Harvard reference or whichever other technique you wish to use. So make sure your references are clear, explicit, and moderators can easily find them. So she derived the rate law with the observed K is the pseudo rate constant K times OH minus. If you have any questions as I go through, please type them into the chat. There is a slight lag between what I'm saying and doing and what you're seeing on YouTube. I can see that on my phone as but hopefully it's not detrimental to the meaning and to the things that I'm saying. Okay. She's then talking about equation below, we've got the Beer-Lambert law, okay, light absorbance and order of reaction. This was not in the original research question. The original research question was the effect of temperature on the rate of the chemical reaction. And now she's talking about using Beer-Lambert to do it, which, okay, she's got some textbook references in there. Chem Guide, typical usual reference. Unreferenced though, we all can see where that came from. And then she gets a bit more confused in here. When the temperature of the sea crystal violet and sodium hydroxide is increased, the absorbance will also increase. But she's referencing the wrong side of the equilibrium or of the reaction. It should be colourless to purple, not purple to colourless, in reference to as reaction proceeds. So this is kind of confused is the word that I'm using here. And as I'm going through, I'm putting exploration as potentially something which I need to look at when we're looking at the marks. Okay. Uncertainties. Now I'll do a little section on uncertainties in a moment. She has put her chosen temperatures of 5.0, 10.0, 15.0, and then her uncertainty is plus or minus 0.5. That's absolutely fine. I'm looking for consistent decimal places as we go through. We frequently see uncertainty, in this case with plus or minus 0.5, and then only 5 or 5.00, and then only 10 or 10.00. So you must have consistent decimal places as you're looking at your variables. Dependent variable, this is correct. It is the absorbance. She's using Beer-Lambert law, so mentions up here. And students often get this incorrect as well. They'll often say it is the rate, or it's Kc, or it's delta G, or whatever quantity they're eventually going to calculate. They'll often misidentify the dependence variable. I don't know if you noticed, anybody that's here that's marks it, the big omission from the controlled variables was the fact that the students did not perform, and this is a common mistake, a limiting reactant excess reagent calculation to prove that she is indeed altering the concentration of the thing that she is studying. Yes, you could argue that's 0.1 mol per decimeter cubed, that's 2.5 by 10 to the minus 5. The CV, the crystal violet, is exquisitely more diluted than the sodium hydroxide, but you still need to prove that you've controlled that variable. It's not enough to say it's obvious, okay? Make it abundantly obvious to your marker. We've now got 10 cm cubed and a classic mistake in consistent decimal places. Each time is 10 centimeters cubed, but it should say 10.0 centimeters cubed. Again, I'm not marking her down for this. I'm not marking anything at the moment. I'm just making comments, and at the end we'll come to a holistic view of the IA. Okay. She does explain why she doesn't explain why she's used this. The trial was conducted at 600.7 nanometers, which is kind of arbitrary. She needs to explain why she has chosen that particular wavelength, and I couldn't find any place in the IA where she had done that. Clearly, she's listened to some things that she's been reading or been hearing. She has put some uncontrolled variables in there, because students often miss those out as the things that you can't do, the exposure to light. She's got fog or mist formed on the side of the cuvettes, and this is all really nice anticipatory stuff, and also doubles up as qualitative data. She did say that temperature is the thing that she's going It's a change, right? What was the research question? Effect of temperature on the rate of reaction. But in her control variables, she has not included temperature. Now that, for me, that's a biggie. That's a big exploration, omission, or error. And this is a common error from students. The thing that you're measuring must also have an uncertainty, must also be controlled. Temperature is notoriously difficult to control. Students will often put a picture, an image, or a diagram of a thermometer which is stuck in the water bath, not in the solution, or they don't allow it to equilibrate, or they don't dry the powder, and they introduce lots of errors which are abundantly obvious to a marker, which clearly students are unaware of. Okay, so that's good. I like that bit. Apparatus, okay, you can include it. Again, we've got 2 decimal places here, 2 decimal places on the uncertainty. That's great. This is by 10 to the minus 5. This is by 10 to the minus 2, so that's inconsistent. 0501, that's okay. And then here, these are all inconsistent because there's no decimal places in the measurement, and there's 1 decimal place in the uncertainty. So again, I'm just putting a little C there for communication, and that's about scientific communication. Clearly the student's using the 1000 cm3 beaker and the 100 cm3 beaker just as storage. It's not used for measuring. They've been complete and put the uncertainty in, but it's perhaps over egging it just a little bit. Okay. We then have a beautiful method. We often get beautiful methods, which are often let down by number. And again, here 10, no decimal places, decimal place, and that's consistent throughout. So communication is taking a bit of a battering as we are going through the marking of this internal assessment. It would be helpful to have an inorganic compound such as propanol of any concentration to wash the equipment with. This is kind of a throwaway comment. There's no evidence of it being used later in the IA. She doesn't refer to it again. It's kind of a bit of a throwaway comment. So communication perhaps. Number again, we've got 10 cm3, 0.2. So here and here. All the same all the way through. Her number treatment, she's getting lots of communication markdowns as I'm going through just the reading of the IA. Repeat with 0.05, and this was omitted. I could not find that in the data. Measure the temperature of the solutions. If they are not, I assume at the temperature, then set up a water bath. But that is not telling me how that temperature was controlled to such a degree of accuracy as they are claiming in the data. Again, we are looking at number, so 10, 0.2, you can see this now. Clearly, there's an issue with accuracy of recording and displaying of data. This is done very well. Safety, ethical, environmental. Often the ethical and environmental are missing. Safety, you can use anything. You can use the occupational safety health and data sheets. You can use CLEAPS from the UK. You can use any of the chemical suppliers. They'll give you fantastic safety data. The environmental and the ethical is often sparsely done, not done, or rarely done very well. What we're looking for is judicious quantities. So here, has the student used the minimum quantities possible to produce the results that she wants to find to address her research question? I mean, arguably she has. She's used 10 cm3. It's a very vanishingly small quantity. So maybe we'll let her have that one. We are generous. Okay. Now, raw data. This was another huge omission. After the exploration, missing how she's going to control the temperature and then seeing that she didn't, a big omission for me was there's no data table for raw data. She talks at length. The 600.7 comes up again. Now she's saying it's the highest peak at 0.4. We all know that 0.4 is quite a low peak. It's not very good absorption at all. Okay, there's nothing I can really pick fault with the rest of that, but there is no data table. She's given the correlation coefficient. We'll assume that's R squared, which means we can interpret the order as first order. This, I don't know how she jumped from this sparsity of raw data to this statement here. so I had quite a problem with that as a moderator. We then have this, which is clearly different text font and style from the rest of the IA. She's obviously borrowed, without referencing this part of the document. It looks like an old paper, and it's probably the research paper she was using for the method that's in here. This is taken from the paper, rate 1 and rate 2, which is fine, it's okay, no problem with that. But then she goes on to make conclusions without any, there's just an absence of data. So on the face of it, this is kind of a very good learning IA, in that it looks like, wow, this student's done derivations of equations, and she's made some assumptions, and she's had a go at uncertainties, and that's all good. But as we read through, oh, this was good. The qualitative data was good in her real IA. These were in colour. It is, I'm sure as you know, a beautiful, beautiful violet colour. Again, in the real IA, I know it's quite difficult to see. Apologies for the scanning on this. You could see these very clearly. She does have error bars, but there's no plus or minus on the x-axis. And I think, what does that say? I can't work out what that says. She does have error bars. She does have an axis, but it's pretty unclear. It turns out, when you interrogate this could be the raw data graph, but it's not clear. This is the first table that we've seen during the internal assessment. And it isn't raw data, is it? It's the initial rate, so she's done the reciprocal of time, s to the minus 1, and put these in. So we have no vision of the raw data. There's no uncertainty on this rate because it's a reciprocal. You're going to struggle with the reciprocal rate. How are you going to get an uncertainty on that? It's possible. Maybe we'll save that for another video. The temperature is consistent decimal places. There's some good in here, but there's a lot that's missing. This one, no attempt at error treatment. I think there is a small error bars that I can just see now after I've written that down, but it is really quite hard to see. Now, if you've seen this IA before, you have looked at this part and perhaps thought, wow, she's done really good. And she kind of has done really good. She's used some exquisite differentiation here to come up with an answer. At t equals 0, initial rate is Beer-Lambert's law, which is 0.1. You may enlighten me here. I have no idea where that 0.1, which is here, came from. Again, we've got the Arrhenius equation here. The correct derivation is there. I think I know where she took this from. Obviously, it's in the data booklet as well. She's got an example calculation of the average initial rate. So she has averaged the initial rate, but she's not put any uncertainty with that. So again, there's another communication here, which I'm going to consider when I give the final scores for this internal assessment. This is 1DP, no DP. The number could be better. Another point, we would expect there to be a new page for a table when you're actually marking this on paper, as you're moderating it, or on screen as it is now. It's much easier just to see what's happened with the data on one discrete table without having to scan through. We then get a Arrhenius plot. This is Arrhenius, yeah, lnk 1 over t it is, and as if by the power of magic and grayskull, we get an activation energy of 53.65 kilojoules per mole. And then she concludes, therefore, the activation energy for the reaction is 53.65 kilojoules per mole. And then we think, but why is she calculating activation energy? Because her research question, what's the effect of temperature on the rate of the reaction? There was no mention of activation energy in the research question, not there, or in the restated research question, which is here. So, you know, it does suggest that the student finished quite quickly and then wondered, what else can I do? Let's add this in, which is not a big issue, but she could have perhaps taken the time to make her research question reflect the adding on of this new information. Okay. So we came down here, we've got a nice graph. She doesn't compare this. You must compare this all the time with your literature value. She must have found a literature value somewhere. And then you can do an uncertainty against your value with the literature value. And that's great data treatment. Okay. Uncertainty of activation energy. I don't see it. The others are root mean square here, 0.2086. The IB don't care how we do the uncertainty, they just care that we actually do it. The student's clearly a biology student because they've got some standard deviation calculations going on in here, root mean square analysis. That's fine. You're not going to get any extra points for doing that. If you just do error bars and absolute uncertainty, that you can still get full points with those. Okay. Uncertainties. So she should have titled this evaluation. She started to evaluate her method and her data, but she doesn't really focus much on the method. There's a lot of missing uncertainties. There's dilution factors here which is not taken into consideration. There was the excess reactants which she didn't address, and it really is quite simple towards internal assessment. The general trend found was that as temperatures increased, the absorbance over time increased, which means that the initial rate of reaction also increases. Again, it's just a standard textbook term or textbook knowledge that we know and that we all teach and learn as we're going through the IB. But it's fine, she proved it, that's okay. We then see the evaluation. It's looking fairly reasonable. She's got a thermometer, but she's got some number, 10%, contributed 80% to the uncertainty in the experiment. That's huge. But she doesn't state what the uncertainty was. It's reasonable, but it's kind of superficial. Insufficient recording time for absorbance. The time was only 200 seconds. Wouldn't it have been wonderful if the student said 200 seconds was chosen and it was incorrect, and I changed it to a shorter time or a longer time, or I worked with the experiment to find the optimum window for measuring the absorbance. That's personal engagement and exploration in a couple of sentences, and she'd been up a few more bands just by saying that. The photosensitive nature of crystal violet can be I have no idea how you're going to control that, but at least you've mentioned it. And she doesn't have an idea of systematic and random error, but there's no quantitative measure. So if there's no quantitative measure of the contribution of systematic and random errors to the overall result, which in this case wasn't even in the research question, then you're not going to be getting higher than 3s or 4s on evaluation. There's no mention of reliability, of validity, of accuracy, of the precision, the standard things that we would expect. And she's not actually compared it with the literature value. Further investigation was fairly superficial. So I've gone through this in 20 minutes, which is quite quick. I obviously spent probably 40 minutes beforehand marking this in depth, so I knew what I was going to say on this live stream. It does look on the face of it a really good high scoring IA, but I did feel that as I dug into it, there were some clear errors in chemistry, and it's all about standing back and looking at the chemistry. Does it make sense? Even if they're proving a known relationship, does it make sense? She got the colours the wrong way around. She missed the limiting reactant. It's almost as though she tried to eclipse that by adding on an extra activation energy and doing a bit of fancy stats in the hope of saving the IA, which she actually did a very good job of saving the IA. It could have been a lot worse, right? Okay. So, the marks for this, is there anybody on the live stream that actually marked this IA that will be happy to share the mark you think it got out of 24 into the chat, please? Okay, we'll thank you, Dawn. 17. Okay, let's have a look and see the scores on the doors for this internal assessment. Nice bibliography, a very poor appendix. There was very little data. So, absolutely agree, Dawn. I gave it 19. I must have been having a great day that day. Maybe I was eclipsed by the wonder of the statistical treatment. The IB sent it back as a 17. So, Dawn Jackson, you completely agree 100% with the IB, and I was too generous. I think Tristan, thank you, 14. As I did on the previous one, on a bad day, I'd give it 1 and 4, 5, 9, 13. I'd give it 16. 16 will be my miserable day score. 2, 4, 6, 11, 15, 19 will be my best day score. So it was one of my students, and I gave him the best day score. I think 17 though is a fair score. So that's kind of like 5, 6 borderline. And when I look at this IA, that's kind of where it's at. There's some really good stuff in there. There's some stuff where the student's gone beyond the syllabus, but there are some clear errors and omissions throughout this IA, which I can't help but penalise for the absence of some more chemistry, which would have made a massive difference. Okay, if there are any questions on that, please pop them into the chat. I'm talking onto my laptop and I'm looking at my phone into the chat on YouTube, so there may be a lag in between any questions. But as promised, here is a 24 out of 24, which was submitted last year. I will say that it did use fancy pants gas chromatography, because we managed to wangle one from our finance department. Be good to use it. So the student's using the effective temperature on reaction rate of Fischer esterification of ethanol and ethanoic acid in the presence of sulfuric acid catalyst. Standard reaction. It was interesting to see, in fact, the comparison between this one and the previous one as we just have a look through. Now, I know I haven't shared this with you. It's the first time you've seen it. I will scroll slowly, and I promise I've asked the author of this if I can share it with the live stream video comments underneath at the end of this. He said, yes, you can, Mr. Midgley. That's absolutely fine. So I will do a bit.ly link to this underneath at the end. Okay, so let's have a look together. It's a standard reaction. It's nothing flash. We don't need to do anything flash to get top marks. We don't need to, be curing world poverty. It's a standard Clark reference, Chem Guide, Ellesmere College. Great reference. If you're not using them for IB chemistry, please use Ellesmere College. They're great. And then we look and we think, oh, this is novel. This is interesting. What's all this? Oh, okay. So we've got the protonation. We've got hydrogen sulfate ion and resonance structures. And we've got concerted mechanisms. And immediately my interest is piqued because the student has done a stepwise sequential mechanism which is not on the syllabus. I think this is on the A-level syllabus. I seem to remember this from the A-level. But anyway, the student's already ticking some boxes on personal engagement and exploration. A standard graph. Some background on GC, because we don't teach it, we don't learn it, we bought it, so we had to learn about it. The students put it into his own words with lots of references that are in there. The standard rate is K, reactants, which are in there. And then it's got the forward and the backward reaction. Again, it's nothing massively beyond the syllabus after the first part. He's then put the delta G in. Delta G is zero equilibrium, as we all know. Kf over Kr is Kc. That's all good. And now he's starting to put in his higher level stuff. Delta G is delta G naught plus RTL in Q for non-equilibrium conditions. We're getting quite excited now. This is pretty good. And then he's got Arrhenius in here. Now the last IA had Arrhenius in there, but this one actually states that that's what he's going to be looking at. Okay, so his research question actually ties in with his method. So it's quite nice preamble. There's a good depth of chemistry. There's a good explanation of what he's going to be doing. And then I'd say the variables treatment here is pretty exemplary from a year 12 IB student. So independent, the thing that you change is temperature. What's the effect? How is it going to be controlled? Well, it's got a temperature probe, monitor the reaction mixture. Brilliant. I can't fault that. 1 decimal place, 1 decimal place. Perfect. Dependent, was the signal outputted from the GC? It could have put the area underneath the peaks, but it didn't. He got it correct. He got 3 decimal places here and 3 decimal places in his uncertainty. It's got 2 decimal places here and 2 decimal places in the uncertainty. Consistently throughout, every number without fail will have an uncertainty associated with it. What happened during, and what were the uncontrolled variables? I do like that. Spontaneous esterification, that could happen, okay, if Q is less than Kc. Vaporized ethanol escaping, it's a volatile liquid, it's got cold water flowing through the Liebig condenser. His apparatus list, I would say, is exemplary. I can't fault any of his number. Again, just to harp on about it, decimal places, consistency, accuracy. And now he has a beautiful image. He's got a photograph put into his IA, which always helps. More decimal places, saponification, how to do it. It's reproducible. That means it's reliable. He's got these GC conditions from the standard experiments that came with the GC, but that's not a problem. He references it in the end at the bibliography, so we can give him credibility for that. Then look at the safety. What is it? What's going to happen? What is it? What's going to happen? And clearly, ethical and environmental is clear, loud and proud. So it's immediately in the top bands for exploration. Results, what we first see, we see a raw data table. We could criticize it and say that the data is kind of sparse. There's not much there, but he is studying one system, and the IB clearly state, don't be shackled down by the 5 measurements in triplicate. There are many ways that we can approach an IA, and this is, although sparse, it did take a lot of time. I saw him do it, so I believed him. By his own admission, he says, Mr. Midgley, I kind of overdid it on this IA. I did too much. Okay, and I would agree. He's just done too. You don't need to do this much, but he did, and it's beautiful. I'll leave that quantitative data table there just for you to have a look at. Again, I will do a bit.ly link, and I will put this document underneath the video when it's shared on YouTube at the end of today's session. It's got an uncertainty on absolutely everything. There's nothing missing. All the decimal places match. I found myself unable to fault that. Maybe you can, but that's pretty exemplary, and it stands out when you're marking it as a moderator that the student cares, they've investigated, they put time into doing this, and they've actually put his heart and soul into making this happen. The IB data booklet makes an appearance, always a good thing, for a delta G for the MR, and he's used PubChem for the density and the boiling points. He's done his calibration, he's done his areas, exemplar calculations for each of the data that he has included. Always put exemplars, even if it's just, there's nothing difficult, this is just a mean concentration after calibration. You're just chucking the numbers in and show you where it comes from. And it comes out with a beautiful number at the bottom with consistent decimal places and units. You can't, there's nothing to fault with that. And we do check the calculations obviously as well. This setting out of calculations as separate boxes and stepwise is beautiful, because we are chemists and we're fairly simple esoteric people. We do like to see where all the numbers have come from. As a moderator, we sit there and we would go through and we'd actually put all these numbers into the calculator and make sure they all come out correctly. And then we see this graph. And again, I think we should stop for a moment and just meditate on this graph here. What can we see? We have temperature in Kelvin, plus or minus 0.5. We have north, south, and east, west error bars on the graph. We have a maximum gradient and a minimum gradient, a fantastic way to ascertain and discuss the magnitude of the systematic and the random errors. Clearly, if the maximum and minimum do not go through all the error bars, then there's some systematic errors which we have not calibrated for, which hopefully he will discuss in the evaluation, which I believe he does. So here's our Arrhenius plot, LNK, 1 over T, bit of a scatter plot. Are there any uncertainties? Yes, but he's put them over here. Okay, they're over here, so they are included. He then discusses the trend in relation to R squared values. He gives a y equals mx plus c value for the line, and then discusses at length the anomalies and the uncertainties. And again, I'll put this under the video. You can have a look at this at leisure. There's a lot to read. It links it into the theory, and then he uses not me. He uses Andrew Weng's table here. What's the equipment? What's the absolute uncertainty? And then he extends it, smallest quantity measured, what's the percent uncertainty, possible effects on data, they're systematic, and what's the improvement. So when I'm marking for evaluation, I just go tick, 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 tick. Of course, we do internal moderation, pass it around to the teachers and go, can you knock any marks off this? And they go, no, we can't. And that's always a good sign. Experimental errors with the dependent variable, with the uncontrolled variables, which if you flick back to the beginning of the IA, actually link back to the ones that you mentioned at the beginning. So that idea of circularity, of setting out to address something, addressing it, and then closing it at the end, is a theme of an excellent IA. What was missing on the previous IA was a comparison with scientific literature. And look, we've got a lovely paragraph. We've got the absolute uncertainty between his value and the published value. I assume that he's put the reference in somewhere. We'll find that in a second. Yep, it's here. And then it links it back to theory. It's got a QC value. I can see 1, 2, 3, 4 references in the first paragraph, and so on. We look at the bibliography, and that's 2 pages long bibliography. He's looked into university references. He's looked into A-level references, IB references. He's researched GC. So as we're looking through, and here's your reference chromatograms at the back for the moderator to have a look at. I would say it's a non-standard IA. It's not a standard, let's do 5 measurements in triplicate and propagate the errors and talk about the systematic and the random errors. But I think it's an excellent example of how you can explore something which you are genuinely interested in and produce a fantastic report. When we internally moderated this, we put it between, I think the lowest was 21 out of 3 teachers, and we put it through at 24. It did come back as a 24, so that's a gold-plated cast iron IA for your information. Okay guys, that's the work through for the one that was shared in the IB Chemistry Teacher Facebook page. That's the 24, which again I'll share underneath the document. If you have any questions, I'll open it up to the floor for the next few minutes if you want to pop them into the chat. I see Tristan's come along. Good to see you, Tristan. Thanks for coming along, Dawn. Getting up in the morning in United States, Eastern Time Zone. And anybody else who's quietly watching on the sidelines, thanks very much for your involvement. Right, on that bombshell, signing off for Friday night. Stay safe out there. Have fun. Thanks for watching. See you later.